So we are excited to be here for our new session of Twist and Taste. This time we are really putting our hands in where things happen, and we are in the lab of quantum machines, and Itamar Sivan is with us to try and share the twist behind the story here, and we're really excited to be here. So I'm Tania Amar. I'm the founder and CEO of CXP Consulting, and at CXP we are storytellers, and we build stories for great startups like yours, so you can really thrive in your international markets.
And I'm Samson, Lewin, and I'm the co-founder now for a year and a half of a company that's called Bluelemon, and we're a performance marketing agency, meaning we do creative performance marketing, so anything that can help startups scale and make money.
Amazing. So I'm thrilled to have you here.
Mm-hmm.
Thank you. Thanks here for having us.
What about you, your background?
Okay, so I'm Itamar, and I'm the CEO of Quantum Machines, which is where we are right now, and a bit about my background.
Mm-hmm.
So
Yes,
I'm a quantum physicist by background, which is why Quantum Machines is operating in the field of quantum computing. Started the company about 3 years ago, and here we are.
What do you guys do? in simple words.
In simple words. So quantum computing is a complicated field, so I'm not sure how much I can simplify it, but in general, quantum computing is about realizing the potential in computation in quantum computers, which is a potential for computational power. So quantum computers could potentially unleash immense computational power, which is far, 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 far beyond anything we could ever get from the computers that we have today. And at Quantum Machines, we develop the systems that operate and control quantum processors at the heart of quantum computers and allow to realize their potential. So we're actually here all about accelerating the realization of useful quantum computers that we believe can impact each and every aspect of our lives.
This is really ambitious. I mean, we were really impressed by the ambition because the players here are giants, right? It's IBM, it's Google. There's a race there. A lot of money has to be invested. So what gives you the ingenuity or the drive to really compete with these guys?
So we're not going against them, just to make it clear. Like many of the companies that you mentioned are potential customers of ours.
All right.
Others may be customers of ours. So we actually work with them, part of the ecosystem to make quantum computers useful and impactful for the industry, right? And indeed, a lot of money has to be invested and a lot of resources have to be allocated to make this happen. You know, startups are meant to be ambitious. I mean, they're founded because people believe that they can do something far better than anyone else. And we felt like we have a good idea to address an unmet need in the field of quantum computing that can make a huge impact. So we were confident enough, or you may say, like many entrepreneurs, maybe arrogant enough to go for it.
How did the idea actually came?
Okay, good question. So it all started with, so Jonathan and myself, we were at the Weizmann Institute. We started the entrepreneurship program over there, and we worked with many entrepreneurs on starting ventures, right? And then we were pinned to start a startup. And we were looking for ideas, and then we realized that we must find an idea in quantum computing, because that's the domain that we care about for many, many years and we're experts in. And as you said, so we partnered with Nissim, which we also know from Weizmann, and who is a world expert in quantum computing. And we set to ourselves the goal to find the biggest unmet need, the biggest problem in this industry, right? What's kind of holding it back, right? Because if you start a startup, you must find a problem, right?
Yeah.
It all starts from a problem.
Not everyone does that, but great start. Just start with a problem.
Yeah.
Some people start with technology and then they look for problems.
Exactly, and that was basically the most natural thing for us to do in the first place, because we're actually scientists by training. So we read the book. You know how do you go about a startup?
Yeah, lean startup. Right.
So we partnered with Nissim. We tried to find the biggest problem holding quantum computing back. We realized what it is, and then we said, okay, let's solve this problem.
So what it is?
The biggest problem that there is, there was that you have quantum processors, right, which have immense potential for computational power. But then even if you have the best quantum processor in the world, it does not mean that you can realize its potential. It's a bit like thinking of a muscle. Like I can have a huge muscle that can do extremely heavy lifting. Yeah, it can lift up a whole building, right? But however, if it has no brain, of course it will lift nothing. So we realize that even though we have these muscles, these quantum processors that could do incredible things, we must develop something that would realize their potential.
Are there many companies doing that? I mean, this is also the second thing, right? Then you look, if your idea, you don't have another 50 companies doing the same thing, right? So
yeah, so I could say that we were the first company in the world focused on that. But that was 3 years ago, and by now there are a few more. So yeah, large corporates, especially in the U.S. and Europe. However, I do feel confident saying that technologically we're far ahead of everyone else.
So basically, it means when you mean building the brain, it means actually building the computers or that gonna operate the processors, like the way a language that we can talk to them.
So that's part of it, right? So we're developing at the core of our system is a processor, a classical processor. That is aimed at connecting to the quantum processor and operating it. Then the interface to our processor is indeed a language that allows you to seamlessly program quantum algorithms on a quantum computer.
So
right?
It's a new language? Or?
It's a new language.
Ah, right. You created a new language?
A new programming language, yeah.
How do you think you actually made something different?
So that's part of the twist, I'd say. And in fact, it's a good question of what is the twist, because if you ask like 3 years, like for 3 years, if you would ask me for like every 6 months, what is the twist? Maybe every time I'd give you an answer. So maybe we need to gather every 6 months from now. But I think that, yeah, this is part of the twist. The twist is quite complicated. I don't know, maybe in most people that you meet, then you ask what is the twist, and there's like a sentence explanation. But here,
not really. Every time it's tricky.
Yeah.
So it's really interesting to hear.
Okay, so as I said, at the heart of our system is a processor, which has incredible capabilities, right? And in many cases, there is a trade-off between having a processor and how much it is advanced and how complicated its language is, right? For example, if I have a super advanced processor, its language will be super complex. Therefore, it will not be human readable or writable. So no one will want to use it, even though it's super powerful. On the other hand, I can develop a language which is super easy, human readable and human writable. But that would mean that the processor that is aimed for it is poor. It does nothing. So the twist here is to separate these two things. So what we did is we have a processor which is super capable, and it has a super complex language interface. And then we built another layer of a compiler, which is in standard words is like a translator, like an easy language to this complex language. And then the whole package is like you have a simple language, super intuitive, human readable and writable, and a processor which is super capable.
Right.
So this is in a way the twist.
I'm really curious because we hear really where things happen and in the lab. If you can tell us what we see here, what are these machines?
This is our first product. Basically at the heart of this machine is our processor. And this is a product that you can then scale up. So you can take 100 of those, connect them all together, and then you have a huge machine that once you connect it to a quantum processor, it can actually operate it optimally.
Can you tell us the impact, in our lives, I don't know, today, already now, what's the impact
of quantum computers? It's nothing. Quantum computers are useless today. We believe that we're, let's say, a few years away from having useful quantum computers. And the impact of, once we have full-scale quantum computers is, well, allow me to kind of avoid a direct answer, is going to be immense. I think that practically, many people talk about potential applications, but I believe personally that, it's in fact very difficult to anticipate even the scope of applications that we'll see from quantum computers.
So Itamar had a great TED Talk that I saw.
Thank you.
And maybe you can say something about exactly what we just discussed now.
So when they asked me to give a TED Talk, they asked me to give some applications. So what are we going to do with a quantum computer?
Right.
And then, I sat down and tried to think, and, I came up with a cliche list of things. that people talk about. But the conclusion that I got to is that really this question doesn't make sense. So it's not like you asked the wrong question. I mean, you asked the right question, but the question doesn't make sense because this is going to be such an advanced technology that it is really impossible to anticipate. So I gave there an analogy. It's like asking a caveman what's going to be the impact of a computer. I mean, how would a caveman know? You're using stones to make fire, right? So his imagination cannot go there.
But you still need some kind of way to project yourself, right? That's because otherwise you wouldn't just invest your time in it, right? You know there's going to be impact.
So there's there's the cliche list of things that people cite, like drug discovery, like finding medicine far faster, optimization of investment portfolios, and
what we know
and
now,
so on and so
what
forth.
What you say is that we don't even
but
know what we're going to
like
need.
what I have in my imagination for the potential things that we could do, I would even rather not say it because it will sound like sci-fi. Okay, and I would be taken for like a sci-fi person.
So this is really where I come back to the question I started, like, so why start a startup? It looks like we're still researching because startup is here to make money, right? It's here to have a business, an app you can sell to a vertical, and it looks like here we still need to develop, we're still at the research stage, so something doesn't connect. Yeah, how do you make it a business?
It's a good question. So I'll say two things. So first of all, you can start a startup with like mere ambition, out of the true belief that there is something at the end of the tunnel that can make a huge impact, and you can get the industry or society or humankind, whatever, to the end of the tunnel faster.
Speed up. So you want to speed up the.
So we're here in order to accelerate the realization of useful quantum computers, which we believe will be able to impact all aspects of our lives. Of course, if you impact all aspects of our lives, then you have a big business, no doubt about that.
That's not what motivates you, apparently.
Right, that's the motivation. However, there is in the meantime, I mean, these systems are sold for a great number of customers. I cannot name the number, but let's say in 15 countries, so all over the world, all types of organizations, from academic institutions, government labs, startups, multinational corporates. We're selling to everyone. Because the thing is that if you're developing a quantum computer, whether you're a government, you're a corporate, or a startup, or an academic team, you need to operate your quantum bits or your quantum processors. And for that, if you want to do it optimally, if you want to realize their potential, so you better use this one. I'd say that once we get like a serious engagement with a customer, we meet him or her, and we show a demo. From that point on, it's super easy. They see it, they understand it, and that's it, right? And normally, like, the conversion rate is super high, super high. However, getting to this stage is the challenge, because there is really a new paradigm in that system.
You have some education to make, like to show the way you do it.
And if they don't know yet of the new paradigm, they may be skeptical on coming to a demo. Like, okay, I've seen such things, like, maybe it's a bit better, but I don't care, right? But once they get to the meeting, they see it, they're like, wow. I actually had a potential customer I met in the US like a couple of months ago. It's a nice story. Like, we sent him, I don't know, a dozen emails in the last couple of years, cold emails, never answered. And then we came to his office and like we knocked on the door. We told him we were going to be there, and he was like, he opened the door. He was like, "Oh, you're here. Okay, let's get it done. Just show me the demo and let's get it done."
That's the chutzpah, right?
Yeah,
That's the here it comes.
So then we showed him we started the demo, and like half an hour into the demo, he said, like, he was literally
blown away.
He was literally saying, like, what have I done? Why did I ignore you for so long and resort to all the, I won't say anything nasty, but all the other things that there are on the market? I wasted my time, right? So, and this is an example.
So what do you learn from that? Because it looks like you also maybe mispresented yourself through, I don't know.
What do I learn from that? Maybe what you know for many years. Marketing is difficult. Marketing is difficult.
Even more in your case, where you have to actually, in a very simple words and very simple way, and once like snap, explain people that what you're doing is actually a revolution.
Yeah.
And the difficulty is, one, that if it's a new paradigm, a single snap is almost impossible. And the second is that
this is people's attention. They
yes,
give you
you need real attention. You need real attention. So whenever you do a snap to explain something, it's always like hand waving from the point of view of the customer. And the most difficult thing on top of that is that anyone can do hand waving. And you find yourself like with competitors which have no technology whatsoever. But they say the same thing. They say, we have XYZ. Do you know what XYZ is? Has no clue. But he says he has it, right? And this is when it gets really challenging.
So maybe we can talk about also a challenge, and one of them that I'm thinking of, but you might have many more, is like the recruitment. We see what's going on in Israel right now. It's craziness. We have billboards out there. You can see it, guys, but people are buying billboards to recruit. So the whole branding, employer branding. So what's the challenge there in the recruitment, and what type of people are you looking for?
It's a general challenge for everyone, for some positions more than others. Yeah. I think that our advantage in this regard is that we're operating in a field that is unique, and we're doing things like we find many people that, they don't want to roll into just another SaaS company, just another cyber company. I've been there, done that, right? And they want something a bit new, right? They want to learn new things, be exposed to new technologies, to a new future, right? And this is something that is truly unique and allows us to.
Can you hire actually people coming from like Monday.com or SimilarWeb? Like that's another
like
SaaS
what
company,
profiles,
or do you need some kind of like?
Yeah, no problem.
Physics,
Yeah. So we have like the diversity of people here is incredible. So we have software people like all over the software scope, pretty much. Hardware people, hardware engineers, logic designers, verification engineers, algorithmics developers, physicists.
Those guys are the hardest to find, right?
The physicists are not the hardest to find. No, because many of us are physicists, so this is kind of our backyard. Right?
Okay.
So,
your friends.
Exactly.
So I have to ask you that question. Do you have women in the field in your company? Do you see women interested in that field?
Of course, yeah. I'd say in general, not enough, but it's not because we don't hire enough. It's because there aren't enough in the industry, right?
Yeah, it's always true.
And I'll say that the acceptance rate of women that apply is far higher than men, by the way. Not because we're doing any prioritization, just because it seems like on average they're better. So yeah.
I have two frustrations of things that we talked about earlier and I didn't pursue. The first one is, what the hell is your vision for quantum computing? That's sci-fi. And the second one is, we're starting talking about marketing, and I wanted to see if you actually guys thought about a way to solve this issue of like everyone saying the same thing in the market, or if it's still a struggle.
Yeah, so these are two great questions. You won't get an answer for the first one.
Okay.
I'll let you, when you go back home, when you go to sleep, just close your eyes and imagine the craziest things you can. So that's for your first question. I'm deeply sorry for that. So the second question was about how do we go about this challenge? So this is something that we're now doing deep thinking about.
Yeah.
It's not a small challenge. It's a rather big one. I can say that as a scientist, I have underestimated the importance and the risk in marketing, and the importance of thinking like from strategy downwards, right? And now I have learned what many people know for many years. But okay, you cannot learn everything in a snap,
too late,
right? So,
I feel like you cared about this from day one, right? Like it's one of the first thing you did. Like you actually.
That's right. We thought that it's gonna be like and punch and we're done, right?
Yeah.
Like let's think of a strategy and let's move, right? And then let's do the tactics. Let's do the collaterals. Let's do the talks, the messaging, the whatever. Like everything will follow. But strategy has to change. Strategy is not like you do strategy and then for 30 years you just keep on making materials based on that. Yeah. Because your competitors, within a few months, they understand your strategy. You're out there. And also, I think that on top of that, like what Quantum Machines is aiming for is being the leading company in the field, right? So, I mean, in a way, if you're not to underestimate any company in the world, but still, like there are mature industries, like again, cybersecurity. You can do amazing marketing, strategy, all along, continuously, change the strategy, build the tactics, do all the materials, all the demos, all the brochures. Everything is spectacular. 10 out of 10, right, for 3 years, but you're a cybersecurity company number 120.
Right.
Yeah, just because it's like a huge industry, very mature,
And it's very
you're
niche,
taking a
right?
niche,
Yeah,
right? You're
it's very
taking a
niche-y.
niche, right?
Because it's matured, so everyone
Yeah,
has his
so-
own little...
Exactly.
Yeah.
And since we're in an emerging industry, and this
When you
makes
say-
it more
When you say
difficult.
industry or field, what do you mean?
Quantum
do you mean-
computing.
So leading quantum computing as an industry, and not one field.
Your niche.
Yeah.
Yeah, I mean, one
It's
can.
hard to be a leader. I mean, it's great you were early, so you were pioneering. But then it's really hard to stay there because everyone's after you, right?
Mhm.
So it's really sometimes harder. Sometimes when you're number one, easier. You're number two. I'm saying, you're like always. You have where to go. But when you were the first, we expect from you to come up all the time with the next thing.
Yeah,
right?
so maybe I
it's
can
like a
address this
huge
point.
commitment.
So, not to be too arrogant or anything, okay? So, I mean, you look at computing in general, right? I mean, there are plenty of leaders. Intel is a leader in processors, so is NVIDIA, more in GPUs maybe.
Right.
AWS is leading in cloud computing. It's not like you have a single player that is the ultimate leader,
Of
right? I
everything.
mean, you can say, okay, this company has the biggest market cap, right? But okay, it doesn't matter. Like, who's the leader? Like, there are many leaders. So yes, so we want to be one of the leaders, of course, through our layer, right? It's not detached in this industry, and this is something that is possible since this industry is emerging. Just like when other industries emerged in the past, like Microsoft has been the leader for so many years. I think that if you do it
takes
right,
a lot of
you,
attention from the CEO actually, and
Yeah.
it's great. It sounds like you have really a big awareness of it now,
It's a difficult.
and the price you're paying when you're not doing it, as
Yeah.
something that's part of the business.
that's right.
Integral
So how do you concretely do this? Become the leader in the industry. What's the plan?
You need to keep on innovating, right? So in the technology, in the marketing, as you said yourself now, in the sales, right? And you need to keep on growing fast.
Never
Never
stop.
stop. Never be, by the way, never disregard anyone. Like, they all have very smart people, very ambitious people, very talented people. Both are
And you have
competitors.
the same goal. Actually, it's really nice what you're saying, because at the end you're all pushing this market forward, and you have that same
Yeah. So there's.
dream.
In fact, there is a single thing that will make that makes the difference. We work harder. That's
All
true.
comes
Honestly,
down to
this is what the only thing what
Can
I
you-
believe for many years. That's the only secret sauce. Work.
Can you bring
harder than
something
everyone
about
else.
the Israeli, secret, or do you think this is related to a DNA, Israeli DNA, or it's just the people you brought in?
I don't know. So this is like a question that many people have, been looking into. So I don't know if I can say anything too smart about that.
No, but in your case, in your company, like
So I-
specifically.
I can't generalize in just my opinion. Israelis are by nature a bit more arrogant. There is a strong feeling of, I can do it in Israel. That's what I believe.
Yeah. Nothing's too big, right? We want.
We can feel it.
Yeah,
in
and there's
nature.
no one better. I think that this is something like of like also like the kind of the Israeli mom or the Jewish mom, which is always like, kind of like you're the best. Like, never mind, maybe he's average, but you're the best. You're better than everyone else.
So you believe it, right?
Yeah, and then you believe it, and then
I
so yeah, I think that this is something, and then you grow up, you see someone like super successful. Yeah, he's not better than me. I can do it too. I think it's mostly about like the approach. Yeah, about
State of
education,
mind,
like
the
from home.
mindset, yeah.
Yeah, the mindset that you have, like an ambitious mindset.
Right.
Just like, the Silicon Valley mindset is like, you can do it. You can start the next corporate that will change the world. They get it. They get this aspiration from the universities.
All right, so we usually wrap up our discussions with a question about innovation. So we talked a lot about innovation in different domains.
Okay.
So what would be your definition, if you can in one word, but you can also
You can do two.
go crazy and longer.
One or two, both are impossible.
A few words.
My feeling is that innovation is using one's intuition to bring something unexpected.
Wow, I love
So I don't know if everyone can kind of feel this definition, but I know that I'm honored to work with so many smart people, starting of course my partners Jonathan and Nissim and all of our team here. super smart, and I'm honored to be working with him. And it happens to me very often that someone just says an idea, which I find innovative, and I'm like holding my head like, what the hell? How did he come up with that? Seriously, it happens to me very often. And then the way I feel is that he really used his intuition based on a lot of kind of expertise and engineering knowledge, but eventually it's his intuition that kind of mashed up some stuff in his mind and came up with something that I did not expect. And this is why I always have some surprise and also kind of I'm happy to hear.
Intuition happens here actually with all the, you're very scientific and you bring more. Even from here, our intuition often comes very spontaneously from a lot of.
So after all, intuition is part of processing. So it comes from the brain, just like anything else.
Right.
But
it's just you're talking about the human side, actually, of innovation, right? You're talking a lot about the people bring that light.
So you can apply to anything,
Amazing.
right? It's like a good joke is innovation to some extent, right?
For sure, for sure. It can, of course.
Unexpected,
comedians are brilliant people. It happens to me with comedians very often. I hear a joke, and I say like, hell, how can the human brain connect these independent things instantaneously into something that not only makes sense but makes you laugh? And this is also related to unexpected things, because the things that make us laugh are the unexpected things above all. Relation between unexpected and funny.
And you can feel it when it's right. Thank you so much.
Thank you so much.
Yeah, we have to come. You said we have to come back in another 6 weeks, 6 months to hear the next twist.
The next twist.
So
we do have a taste.